All right, this is Mr. Smith here. This is Algebra 2, and we were working on section 4.7, part number 2, completing the square. Okay, and so the goal for this section is that I'm going to go through these two problems here, and then I'll give you a few that you can work on at home, and then we'll look through those answers as well. Okay, so the process of completing the square is to try to write this left-hand side as some quantity x minus or x plus some number quantity squared equals some number over here. And I don't care what the number is on the right-hand side because I'm just going to take the square root of it. But what I need to happen is I need to be able to write this left-hand side as some quantity squared. And so I need to adjust the left-hand side to do that. Okay? So in this case, I'm going to subtract out the 7. So I get x squared minus 8x equals negative 7, and I left myself a lot of room because I know that I'm going to add in a number on both sides of the equation. And the number that I'm going to add will go right here. And the way that we calculate it, I showed this in part 1, showed this yesterday, but we take this number divided by 2 and then square it. Okay. And so I take, again, the number that's attached with the x, we divide it by 2, and square it, and that's the number that I'm going to add to both sides. So 8 divided by 2 is 4, 4 squared is 16. And now this left-hand side will indeed factor just the way that I want it to, namely into x minus 4 quantity squared, and that will equal 9. Okay. And that is the process of completing the square. That is the process of completing the square. Again, we add some number to both sides so that I can add the left-hand side, or so that I can factor the left-hand side into this quantity squared, and now we just apply the square root method from here. Okay, so we take the square root on both sides, and we get x minus 4 equals positive negative. The square root of 9 is just 3. So x minus 4 equals positive negative 3. Add 4 to both sides, x equals 4 plus minus 3, and so therefore x equals 7, or x equals 1. Now if we get all the way down to these really nice numbers, again, 4 plus 3 is 7, 4 minus 3 is 1, it also tells us that we could have factored. Right? We actually could have done this whole problem by factoring, and if you can factor, you much rather do it because I think it's a little bit of a nicer nicer approach. However, the completing the squares method will always work, and so you don't have to try factoring and find out that factoring doesn't work and then go to this other method. You could just start with completing the square. Okay. Let me do this next problem, and then I'll show you a couple that you can work on individually. And so we never do completing the square where the first value is greater than 1. Okay. We don't do completing the square with a value out here. We have to get rid of this. And there's a very easy way that we can get rid of it. It is to divide it out. Okay. We just divide it out. And remember, we're going to be solving equations, right? This is a process to solve equations, so you'll always be able to divide out this first number, whatever it is. Okay. So if we divide it out, we're left with x squared minus 10x plus 12 equals 0 divided by 2 is just 0. Remember, everything got divided by the 2. Okay, so including the 0, but 0 divided by 2 is just 0, so that piece is there. Okay. And now I can proceed with completing the square. So the first thing I want to do, I'm going to try to distinguish my problems here. First thing I want to do is move the 12 over to the other side. So it gives us x squared minus 10x equals negative 12. And now I need to pick some number to add to both sides so that I can write this left-hand side as some quantity squared, namely x minus some number. Okay. Again, the procedure, the process that we do is we look to the middle term, and we divide this by 2. So that's 5, and then we square it, and that tells us the number that we're going to add to both sides, in this case, which is 25. Okay. And now I can see how this should factor. This is going to factor into x minus 5 quantity squared equals negative 12 plus 25, which is 13. Again, I don't care what the number is on the on the right-hand side, because I'm just going to take the square root of it. Just going to take the square root of it. Okay? And so with that being said, let's go ahead and take the square root. So we have x minus 5 equals positive negative square root of 13. That's not going to simplify, and so our final answer is x equals 5 plus or minus square root of 13. Okay? And again, the first step, the first two steps are really the process of completing the square. Once we've completed the square, now we just use the square roots method to finalize the answer. Hopefully you guys are getting good at the square roots method, and hopefully completing the square doesn't cause you too much difficulty. Again, completing the square will always work. Okay? Now it's nice when the middle term is, again, even, because when I go to divide it by 2, that means I'm going to get an integer value. But the process still works even if this number isn't even. Right? You just get decimal values. Rely on your calculator a little bit to help you understand what numbers you're going to add to both sides, but the process works exactly the same. Okay? Okay, at this point I have 3 problems up on the screen, and I'd like for you to work on each one of these individually on your own. So you may pause the video now, and I'd like you to work on these 3. Again, just as a review, here we want to get rid of the 4, and then I'm going to add some number to both sides so that I can factor off this left-hand side. Here we want to get rid of the 8. And on this one, the first thing we want to do is we want to divide everything out by 2. Divide everything out by 2, and then continue the process of completing the square. So when you resume the video, I'll go ahead and show the solutions to these problems. All right, well, welcome back. Here are the 3 solutions. I'll kind of go through step by step, but if you are struggling to see it, please just pause the video and walk through each step. So for this first one, I shifted the 4 to the other side, and I see now, based on the middle term here, that I divided by 2 and square it, and so I need to add 9 to both sides. Okay. That factors into x plus 3 squared. 9 minus 4 is just 5, and now we use the square roots method, square root both sides, shift over the 3. Now, one word of caution, when you shift over the 3, remember that you're subtracting it, so it should be negative 3 plus or minus radical 5. Okay. Same idea for number 8. We move over the 8. I then see that I need to add 25 to both sides. This factors into x minus 5 squared. Again, this sign is dependent on whatever the sign is of the middle term. We use the square roots method. X minus 5 quantity squared, square root it. Again, we get x minus 5 equals plus minus square root of 17. That's not going to simplify. And we add the 5 over to get our 2 solutions. Remember, every quadratic equation has 2 solutions. So we expect to see 2 of them. Okay. Number 9 is a little different. Right? First step is to get rid of the 2 up front, and so we divide everything by 2. Again, since this is an equation, it's not an issue. One word of caution, though, remember that you have to divide the right-hand side by 2 as well, but in this case it's just 0. 0 divided by 2 is still 0. And we follow through the process. We get rid of the 7, just put it to the other side. We look at the middle term here, divide it by 2, square it, and that gives us a 1. N squared minus 2n plus 1 factors into n minus 2 quantity squared. That equals 8, 1 plus 7. And now I square root both sides, follow through, and simplify square root of 8 down to 2 radical 2, and we're done. Okay. So this is a very, very powerful technique, right? This always works. And so one mathematician said, well, if this always works, and we kind of have this technique where I can solve any quadratic even if there's a number up front. So let's take it to the next step. Right? And so in mathematics, the next step is always a generalization. And the next step, the last step, the biggest idea is, can we generalize this idea? So here I have the standard form of an arbitrary quadratic where a, b, and c are the coefficients, and I want to solve it for x. And a, b, and c can be any number. So we're saying, basically, if I could solve this problem, I can solve any of them. In one sense, this will create a formula for us based on a, b, and c if I could complete the square on it. And so that's what I'm about to do. Right, I'm going to complete the square on that. So think about the process. And for my students in Algebra 2, my expectation is that you could follow every step. I don't need to see you replicate this process. I'm not going to ask you on a quiz or a test, but I will tell you that in the next class, students were tested on this process and they were asked to do what I'm about to. So it is to your advantage to watch closely. Take notes if you wish. All right, so I want to complete the square. So step one says I never want to complete the square with a value out here, so I need to divide it out. I need to get rid of it. And so that's going to give us x squared plus b over ax plus c over a equals 0, because 0 divided by a is just 0. Okay. So step 2 of completing the square process says, well, this c over a probably isn't the right number I need to have here, so I get rid of it. Right? What do? I push it to the other side through subtraction. So it gives us x squared plus b over a x equals negative c over a. And now completing the square says I need to add some number to both sides. And this isn't going to be a pretty number, but I'm going to add some number to both sides. And what number do I add? All right, so I take the middle term, which is b over a. I divide it by 2. All right, so b over a, and I'll just kind of put this out here on the bottom. B over a divided by 2 is really b over 2a. Okay, b over 2a. And now I'm supposed to square that. So if I square that, that is b squared over 2 squared, which is 4, and a squared. So this is the number I'm going to add to both sides. Right? What did I do? I took the middle term, I divided it by 2, and then I squared it. That's the number I'm supposed to add to both sides. And I recognize that that doesn't look very pretty, but don't worry. We'll make this look pretty. Okay. So I add that number to both sides. Okay. Well, now I know that the left-hand side should factor. Right? I chose this b squared over 4a squared on purpose because I want the left-hand side to factor. And so it should factor into x squared plus b over 2a. Right? It should be just this piece. That should be what the left-hand side factors into. And on the right-hand side, I have these two fractions, but I really want to combine them. And so I know the way that I combine fractions is to get a common denominator. And so the common denominator should be, I see 4a squared and a. So the common denominator should be 4a squared. And the way I'll get that is I'll multiply this guy by 4a. Let me just write this up here. 4a over 4a. And what that'll give me in the top is that'll give me negative 4ac. And that'll give me 4a squared on the bottom. And on the right here, I have this b squared and I have this 4a squared. Oh, and I apologize. On this left-hand side, right, we factored this, and so it should be, wow, I really wrote that poorly. I apologize. It should be x plus b over 2a quantity squared, right? When I go to factor this, it should give me x plus b over 2a quantity squared. That's the whole idea of completing the square. I apologize that I miswrote that. Okay. All right, so let's pause here for a second and go back through the steps. So step 1, I divided out by the a because completing the square says you can't have a coefficient out front. Step 2 is I got rid of the c over a, and then I chose to add some number to both sides. The reason I add that number to both sides is to make this left-hand side factor, namely to this. Now I'm ready to do the square roots method. Square roots method says I get x plus b over 2a, and that's going to equal positive negative square root. I'm going to switch the order of this just to make it look a little nicer, maybe a little bit more familiar. So I'm just going to write, I get b squared minus 4ac, combining the fractions, right? b squared minus 4ac all over 4a squared. Okay. Remember, I'm just adding the two fractions. How do we add fractions? We get a common denominator and then combine the numerators. Okay, so I only have one last thing to do to figure out what x equals, namely subtract over the b over 2a. And if I just take the b over 2a and subtract it over, I get x equals negative b over 2a plus or minus this big square root, b squared minus 4ac all over this 4a squared. And that is what? What is this? Go ahead. This is hard, yes, but what do we call this thing? It's almost the quadratic formula. All we need to do is a few minor surface changes, and this will be the quadratic formula. So the main change we need to do is we need to simplify this bottom square root. All right, so what I'm going to do is I'm going to take the square root of the top and the square root of the bottom. And so we get x equals negative b over 2a plus or minus the square root of b squared minus 4ac all over, and let's think about it. If I take the square root of 4a squared, that should just give me a 2a. But now I see that I have, again, two fractions. Both have a denominator of 2a. And so I'm just going to add those. And so what we get is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And I recognize that is a very complex process to get there. But I hope you can see, number one, and this is key observation. Number one, all we did was complete the square on the generic standard form of a quadratic. Number two, if completing the square always works, then the quadratic formula always works. Number three, when a problem asks you to solve it by completing the square, in my mind, you can use the quadratic formula because it's the square already completed for you. Okay, where does the quadratic formula come from? It comes from completing the square. Again, I hope that you, my students, could walk through this process and see each step. I don't expect you to replicate this, at least not yet. That'll be next year for you. Okay. So with this transitions us into the next section, section 4.8, which deals with the quadratic formula. But for now, this will conclude today's lesson. So thanks for your attention. Have a good day.